That's what we want to do. Okay, so we're going to talk about Mat120, intermediate algebra. Section 4.8 in your book, around page 268, if you have a book. And this is solving quadratic equations. So what's a quadratic equation? Quadratic equation is an equation that has a power of an exponent of 2 or bigger. That's what we call a quadratic equation. So let's start off with this one. Okay, so this is based on a little theory. And the little theory is, if you get 0 for an answer, one of the numbers that you multiplied, or one of the factors, we call them factors, that you multiplied, has to be a 0. If you have 7, to get a 0, you had to multiply it by a 0. You could have also multiplied a 0 times a 0 and got 0. But at least one of the numbers has to be 0. And it could even be something weird like x minus 2. To get an answer of 0, you had to multiply that by 0. So that's how this is based on that idea that if we set these factors to 0, then if they're equal to 0, then we would get 0 for an answer, okay? So that one of the factors had to be 0. It's kind of based on this theorem, the principle of 0 products or something. All right, so let's see if we can solve this problem. The first thing we're going to do is take this equation and make sure it's set equal to 0. That way it'll work. So we're going to bring the 6 over to the other side. We're add a negative 6 to both sides or whatever. We set it to 0. So we call this set to 0. The equation has to be in that form. Can't be a 5, it can't be a 6, it has to be a 0. Then what we're going to do is factor it down by whatever means you used. I'm going to use the x method, but you can use any method you want. Negative x, we need a negative 1 for the middle term. That means it's 3 times 2. It's got to be a negative 3 and a positive 2. So it's going to be x minus 3 times x plus 2. And if you have a different way of factoring them, that's fine. Or maybe you just use trial and error, x and x, 3 and 2. The 3 has to be negative, and because the largest number is negative, the other one has to be positive. Double check it, negative 3 times 2, negative 6. Okay, once that's done, we're going to split each part, each factor, and set it to 0 using this idea. And x plus 2 equals 0. So in other words, for this answer to be 0, one of these factors or both of these factors was equal to 0. And that's what we said, they're equal to 0. Then what we can do is we can just solve them, bring the 3 to the other side, or add a positive 3 to both sides, add a negative 2 to both sides, or we just bring it over, negative 2. Do you believe that's true? Let's check it. Now, I'm going to check the first one. I'm not going to check every problem, but we're going to put it into the original problem. So if I put a 3 here, I got 3 squared minus 3 equals 6. Is that correct? Let's see. 9 minus 3 is 6. Looks like it checks, huh? 3. Okay, what about negative 2? Negative 2 squared minus a negative 2 is 6. Is that going to work? Negative 2 squared is positive 4 minus a negative 2 plus 2 is 6. 6 equals 6. Okay. What if I put a 5 in there? 5 squared minus 5 is 6. 25 minus 5 is 6. 20 is 6. I don't think so. So these are the only two numbers that are going to work, 3 and negative 2. Those are the only two answers. Now, look at your power. Your exponent was a 2. That means you're going to get The maximum number of answers to this problem is 2. You cannot get more than 2 answers to this problem. That's why I know this wouldn't work. So if your power is 2, you're going to get probably 2 answers. You might get less, but you probably would get 2 answers. If your number is 3, then you're going to get 3 answers. If your power is 4, you're going to get 4 answers. The higher the power, the more answers, the more difficult it is to solve. If this problem has a power of 5, you're going to get 5 answers. Very difficult to find all those 5 answers. And it doesn't guarantee those are all real numbers. What are real numbers? Real numbers are all the numbers on the number line. All these on the number line right here are real numbers. Okay, all the numbers, 0, 1, 2, all the numbers between them, -1, -2, all the numbers between, all those are real numbers. So you're saying, well, how could you get answers that aren't real numbers? Well, there's actual other numbers out there. There's numbers in this space up here. They're floating out there. You just can't see them. But next course or next semester, you'll find them. Okay, but right now, all we're confined to is the real numbers. Later on, we'll find out the real numbers is just a set of numbers of a larger set and complex numbers. So we're going to explore those later on. But right now, we're just looking for real numbers, real exciting numbers. Okay, with all that aside, let's try another one here. Let's suppose you were walking down the street and a person met you. You met this guy, and he walked up to you and says, "I'll give you $1 if you can solve this problem." You say, "Oh boy, $1. You're pretty excited, aren't you?" Okay, so you say, let's see if I could do this thing. Well, what's the first thing you would think you would do? Drop back 5 yards and punt? No, I don't think so. Okay, the first thing you would do is say, I need to put this in descending order and I need to set it to 0. Set to 0, and they have to be in order. Set to 0 and then order the problem. So let's put the y squared first. 3y squared, let's put the 7y next. It's still going to be the same signs. And let's bring over this 2. Hey, buddies. I'm over here to help you out. Okay, let's factor this down. You can factor it any way you want. I'm going to use my little method here. 3 times 2 is 6. This is 7. 6 times 1 is 7. It's got to all come out positive, so it looks like we're good. So this is going to be 3y plus 6 and 3y plus 1 equals 0. Now I'm going to show you something. Usually we reduce this, right? We divide this by 3. But what if we forgot? Oh my God, I forgot to reduce it. It still will solve out. Okay, if I reduce this to y plus 2, divide both of these by 3, y is going to equal -2. If I set this to 0, let's see if it still equals -2. I'm going to set this equal to 0. And this is a pretty easy part. And set this equal to 0. So I'm going to solve this. I bring the 6 to the other side, -6, and divide both sides by 3. Y is -2. It probably would have been smarter to divide both of these and reduce it down, and get this problem right here. But if you forget, it still will work. You see, this would give you -2 also. Now, what about this one? 3y equals -1. Bring the 1 to the other side or add a -1. Divide everything by 3, both sides. And y equals -1/3. Yes, Virginia, there are fractions. Sometimes these do come out with fractions. So who would have even thought of these 2 answers for this problem? That y could be -2. I mean, how else could you do this? Could you do this in your head? Just randomly, I just figured -1/3 would work for this problem. I don't think so. You could try a month and a year putting different numbers in and you might come up with these solutions, but very doubtful. So a very quick way to solve a quadratic equation, just taking both of these answers and using them to solve a problem. Also, I'm going to show you something nifty about these two answers. This is these two answers on a graph are going to indicate where the graph crossed the x-axis. It crossed it at when x was -2, 0. And it crossed it at -1/3. If you can kind of see that right there, 0. And the graph was coming downward and went through those. Now, we don't know how far this graph went down until we do some more math, but at least we can get an idea of what the picture would look like. So these are also called x-intercepts. This is where there's several names for these. Okay. I remember when we did this in school, back in high school, and I think I was absent that day, and I never missed much school, but I think that particular day I missed school. And the teacher was talking about the roots of the equation, the roots. And I'm going, what the heck is he talking about? So sometimes we call these roots. Sometimes we call these answers. Sometimes we call these solutions. Sometimes we call these zeros, zeros, the zeros of the equation. They're called zeros because the x term where it crosses the axis is a number, and then the y term is 0 because we set this equal to 0. So sometimes these are called the zeros, roots, zeros. You might see these intercepts, x-intercepts. They all mean the same thing, just different ways we describe these answers. In this case, the equation was equal to y. Most of the time it's equal to x. But so this probably would have been on the y-axis rather than the x-axis. But anyhow, these are called roots, answers, solutions, zeros, intercepts, x-intercepts. Kind of interesting. So if you hear somebody say, what are the roots of that equation? You know what the heck they're talking about. Here's some more paper. Let's see if we can do some problems. Okay, let's try another one. Let's try this one. This is on page 275. B squared equals 10b. What does that say, by the way? B squared and by's. Sorry. Okay, just reminds me of old saying. All right. Again, you might look at this problem, and let's say some of you say, well, I can solve this a lot faster, Mr. Mitchell. I can just divide both sides by 2 and then by the b and get b equals 2. Well, the problem with that is you only got one of the answers. You didn't get both of the answers. So we want to be kind of careful on trying to do some problems in our head, you know. So let's move this 10b to the other side. You always want to take a quadratic equation, power 2 or greater, set it equal to 0, because that's the 0 principle. It has to equal 0. Can't equal 5, 6, 7, 8, just a 0. Factor this out. Now we can use common factoring. We can take out a 5b. That's okay. It doesn't always have to be a little different problem. Okay, it doesn't always have to be a formula, but it doesn't always have to be, you know, X method or something like that. It could be just basic factoring. So this ends up with b minus 2. But we want to factor it out. And this is still factoring. We're going to take each one of these factors and set it equal to 0. 5b equals 0. And b minus 2 equals 0. Okay, so if 5b equals 0, how do I solve that? Well, you can kind of think, well, 0 times 5 is 0. B has to be 0. But we can also divide both sides by 5. Can you divide 0 by 5? Oh, calculator, 0 is Turn it on, clear it out. 0 divided by 5. 0? What? 0 divided by 5 is 0. Yes, we can. Can I divide 5 by 0? Can I have this upside down? Let's see. 5 divided by 0 is divide by 0 here. You can't do that, but you can divide 0 by 5. 0, which makes sense. 5 times 0 is 0. Okay, so 0 is a very common answer. It does come up a lot. Now let's bring the 2 to the other side. B equals 2. And so we got our 2 answers. Pretty easy to do. And we can see that this graph, even though it only has kind of a weird looking thing, it's going to go through 0 and it's going to go through 2, and the graph's going to come down like that. And we don't know how far. Figure that out. And then we can solve that a little bit later. How do we find this point? Well, we can use some algebra to find it, or we can use calculus. And we can find that turning point. Okay, let's try another one here. X squared minus 6x plus 9 equals 0. Okay, well, maybe you remember this. Is this a perfect square trinomial? The square root of 9 is 3. 3 squared is 6. Yes. Even though it's a negative, it can be negative or positive here. Yes, that'll work. So this is a perfect square trinomial. First term gives me the x, middle term gives me the sine, last term gives me the 3, and I give it the square equals 0. The only thing when we go to solve it, we probably want to split it up into 2 parts and then solve each part. Well, both parts are going to come out with the same answer, aren't they? Bring the 3 to the other side. The same thing is going to work here, bring the 3 to the other side. So we get the same answer twice. When this happens, we say the answer is 3 with multiplicity, big word, of 2. Happens twice. 3 with multiplicity of 2. Slide this way over here so we can kind of see it. Okay. Okay, so that's what that really means. Okay, but our answer is just 3. So if we had to list the answer in a set, we would just say it's just 3. We don't have to write it down twice. So 3 is the only number that works. Well, you're saying, well, what if you graph it? And you put 1, 2, 3, you got this little 3 with a dot. Well, that means the graph is coming down, but it's hitting that point and bouncing back. So this is our turning point right there. 3, 0 would be our turning point of our graph. The graph won't go any lower than that. And because it has a power of 2, we know it won't cross the axis again. Okay. So let's try another one here. Here's one with a cube in it. Okay. If you have any questions along the way, that's your problem. No, we'd be glad to answer them if you have anything that comes up. So what do you think on this one? Let's bring the 30x over. Let's make sure these are in descending order, all that good stuff. A little bit more challenging problem. But we notice it ends in x, 39, 3. We can take out a 3, 3x. So we're going to factor that out. That would be x squared. Would that work? 3x times x squared minus 3x times 3x would give me 9x squared minus 10. 3x times 10, 30x equals 0. Let's factor this one down. Keep the 3x. This would be x. and x, and I'm going to make a long story short, this will be 5 and 2, negative 5 and a positive 2. Okay, these will add up to negative 3 and they'll multiply to give you 10. Okay, now we have 3 answers here, but we're going to take each one and set them to 0. Some people don't like to put the bars, and that's okay. We just put the word or between them. Okay, this is an or statement. We're going to divide on this one, we're going to divide both sides by 3. 0 divided by 3 is 0. Here we got a 2. We'll bring it to the other side. X is negative 2. Pretty easy to solve, huh? And here we're going to bring the 5 to the other side. X is equal to positive 5. So we get 3 answers. And those are our answers to the problem. X could either be 0, it'll work, negative 2, it'll work, or 5. But again, we had to take this equation and make sure it equaled 0 and was in descending order. If we go to graph this one, it's going to go through negative 2, it's going to go through 0, and it's going to go through 5. With a little work, we can kind of figure out it's going to come down. It's going to go through that point. We don't know how much it's going to go down. We just have to approximate it. It's going to come back up, and then it's going to go down through this point. And we know it won't come back up because the power is 3, and we can only have, at maximum, 3 answers to this problem. So it cannot curve here and come back down through this, and it cannot curve and come back up. So it's going to come down, come up, come back down again. So later on, we'll be exploring these kind of graphs, kind of fun to do. And you can see these are kind of key points that really help us figure out how this graph is going to go. And then we still need to figure out this point right here, the turning point. This is called a relative min. And we need this point right here, which is called a relative maximum. We need to figure those 2 points out, but at least we got to start. Okay, so that's basically the whole idea behind it. Pretty easy. Sometimes they get a little bit harder to solve, but for the most part, not too bad. Let's try one like this, see if we can do it. Okay. Step number 1, make sure they're in descending order. Okay. Much easier to factor. Second, your quadratic term should be positive. So you want to factor out this negative. Is there anything else, maybe a 2 or a 4 or something? It doesn't look like it. But take out at least a negative 1. And I'll show you what we're going to do with that. Okay, let's just leave that. That'll be 12a squared minus 5a minus 28. See, all the signs changed. Equals 0. Now we're going to factor that out. This one a little bit harder to factor. We could multiply 12 times 28. I'm not sure. This one's kind of tough. So let's see. This is... I'm probably going to go with... I'm going to do it by just trial and error. I could multiply the 12 times the 28, but I'm thinking this is 3a and 4a. And if I'm wrong, so be it. Okay, 28, I'm thinking 7 times 4. I can't put the 4 here, so I'm going to put the 7 here and the 4. Let's see if this will work. This will give me 28a. No, 21a, excuse me. And this will give me 16a. And I need a negative 5a. So outside 21, inside 16, I need a negative 5. This would probably be a negative 21 and a positive 16, huh? What combination gave me the 21? The outside. This should be negative 7 and a positive 4. 4 times 4 was 16. So I think I got it factored in a negative 1. Now we're going to take each one of these factors and set it equal to 0, including a -1. And I'm going to separate them with little lines so you can see. Okay, -1 equals 0 is impossible, huh? Only 0 can equal 0, or -1 can equal -1. So this is not possible. This is not possible. And so this is called an extraneous, fancy word, extraneous solution. Means it doesn't work. Okay, we'll bring this 4 to the other side. 3a equals -4. We divide this by 3. A is -4/3. So we've got one of our solutions. And that would be pretty hard to guess at. And the same thing here. We're going to bring the 7 to the other side, divide both sides by 4. A is 7/4. So the factoring is the hardest part. Taking out the -1, important. Putting them in the correct order, very important. But factoring is the hard part. And this one not being a super easy problem. And that's where the factoring, you have to keep practicing so you get pretty good at this, fooling around. I figured it would be 3 and 4. You can use other methods. However you factor is up to you, but you want to try to do it. The last thing we're going to talk about is domains. The domain of a problem like this means, the domains means all numbers that you can choose from. And on this problem, you could choose from any number you wanted to on the number line. Of those numbers, only 2 work, but you could have chosen any numbers you wanted to try, and you're not restricted. But sometimes when we have a fraction, we're restricted to only certain numbers. Let's take a very simple one, x over x minus 2. Well, let's make x squared minus 4. So we have a quadratic down here. We're not worried about the numerator, okay? The numerator is not going to bother us, okay? We don't worry about that. We're only worried about the denominator, okay? So we're going to take this x squared minus 4, and the way I do it is I say x squared minus 4 cannot equal 0. Kind of a contradiction of what we've been doing. Okay, I'm going to factor this down. I recognize that this is difference of squares pattern, x and x, 2 and 2, opposite sides, plus and minus. So I recognize that. That cannot equal 0. And then I'm going to solve this. X plus 2, instead of saying equals 0, I'm going to say it cannot equal 0. X cannot equal -2. We're looking for the domain, remember. Okay. And x minus 2 cannot equal 0, so I bring the 2 over. X cannot be 2. So what does this mean? This means if I put a 2, let's look at the positive 2. If I put a 2 in here, I get 2 squared minus 4 is equal to 0. I get x, of course, would be 2. But if I put in a 2 in here, I'm going to get a 0. And remember, 2, let's turn this on, 2 divided by 0 is an error. So I can't have it equal to 2. So my domain is, I'm going to write it down here, it's going to be all x's such that x is a real number. This is the abbreviation for real number, make it double R. But x cannot equal -2, and x cannot equal +2. In other words, I can use any other number I want in this problem. I can use a 5 and put 5 over 5 squared minus 5, which would be 5 over 19. I can use any number I want except for -2, because what will happen when I divide by -2, there's no solution. I'll be dividing by 0, and 0 doesn't give me a solution. So I'm trying to find the two exceptions. Otherwise, I can use all real numbers. If you're going to write this using interval notation, it would be negative infinity to negative 2. And we'll leave that as a parentheses. And then negative 2 to 2 would work. And then from 2 to infinity. So that's how you would state it with interval notation. But I think it's easier to state it this way. X is any real number except, you're trying to find the exceptions. That's what you're looking for when you're doing a problem like this. You're looking for the exceptions that will not work. Let's try one more real quick. Let's try this one in the book. They have x minus 2 over x squared plus 2x minus 15. Function of x equals this. So we're going to make sure, okay, when we do this problem, we're not going to worry about the numerator, just the denominator. For finding domain, we just concentrate on a fraction on the denominator. And we're going to set function of x equal to 0. It's with a minus on it. Okay, we're going to factor this by whatever means you want to do. However, when you factor this and say, we know this is going to be 5 times 3, placing the sign is very important. Okay, that's key to this problem. Outside 5x, inside 3x, I need a positive 2x. That means the 5 has to be positive and the 3 has to be negative. We knew they would be opposite signs to get the 2, but where we put those negative signs is key. Because if you don't do that, you're going to end up with the wrong answers. So what we're trying to do is find the exception. X minus 3 cannot be 0. So x cannot be 3. X plus 5 cannot be 0 on this problem because it's we're looking for domain, remember. We're not trying to actually solve the problem. In a way we are, but in a way we're not. Negative 5. So x is an element of the real numbers. You can even go like that, you know. And x cannot equal 3, x cannot equal 5. Even if you don't write all this down, make sure you put down x cannot be 3 and x, look at, I put an equal sign, cannot be negative 5. You're looking for it says, what is the domain? It's better to put down x is a real number or element of the real number. You can put that down. X cannot be 3, x cannot be negative 5. This is just saying x, you're solving for x. That indicates you're solving for x. And, or such that, sometimes this is read such that, you know, that's what it means. X, you're solving for x. X is a real number, but, sometimes I like to write the word but, x cannot be 3, x cannot be negative 5. It can be any other numbers. Okay, so that's all we're going to do. We're not going to do any other types of problems on here. You know, you just want to kind of work on some of these on the domains and on the basically solving them. And then in the next couple of sections, we're going to be using this to help us. But solving equations is very important. Sometimes these will take different forms. Maybe we have a problem like this. Maybe instead we have a problem like this. Same thing. Maybe we have a problem that looks like this. They're all solved the same way. They're using this basic factoring. Delta x minus 2 delta x plus 2 equals 0. Delta x is equal to 2. Delta x is equal to negative 2. So, and you could probably solve these in your head. You're going to take this to the other side. 2 minus 2 is 0. Negative 2 plus 2 is 0. So they're not too hard to solve. Once you get it down, this part is the easy part. Solving them is easy. It's the factoring that's always the most difficult part. Once you get past the factoring, solving the equations is not very difficult. Unless you run into a quadratic equation or something that's unfactorable. Then we can learn some techniques. So, do you have questions? This is your opportunity. Ask anything. What about some of the past things? Make sure you're getting your work in. I think you guys are very good about doing your work and turning it in and stuff like that. If you're a little behind, make sure you get caught up. Get all your stuff in because time's running out. And this is a time of the year where you're kind of burned out. Thank goodness you have tomorrow off. You can kind of rest up. And you're going to have Thanksgiving coming up. And then after Thanksgiving, bing, bada, bang, we're done. So it goes really fast and you're thinking about Christmas and all that good stuff. So it's kind of hard, to stay on track. And usually the course gets a little harder towards the end. So it's kind of staying with it and getting through it. Then we're going to use most of this stuff for the next course coming up. In that class, this class is kind of a review of a lot of the stuff you've had, but the next course will be pretty much new things that maybe you haven't had or things that were difficult in Algebra 1, the parts that towards the end of the year, maybe you didn't get a lot of that stuff. So hopefully this lays the groundwork for it. If you have no questions, I'm going to sign you off. I want you to have a good day. Take tomorrow off. Relax. Okay. Remember all those people that died for you.